On this lesson, we will be discussing the law of cosine. So first, let's start by looking at this introduction question, which says use the distance formula, which is stated there, to find the length of line segment z. So at least we want to come up with a equation that perhaps we can use to find the length of this line segment z. But what do we notice about this triangle? Well, first of all is take a look at where the vertices or vertices of this triangle are located here. So we have a triangle here, that's A, that's C, and that's B. So notice that my triangle, one of those vertices, is located at the origin of an axis. And here we have 2 points. I mean, if I want to find the length of line segment C, then I can definitely just find the distance between point A to point B, which notice that A, the x coordinate of A can be defined as B cosine of x, and the y component of coordinate A can be defined as B sine of theta. The x component of the x component of B is A, and the y component of B is 0. So we can just use this as my two coordinate points for my distance formula. So let me call A my x1, and let me call B cosine my x2. Let me call 0 y1, and let me call B sine my y2. And note that if I find the distance between these two coordinate points, I will definitely be finding the length of C. So this now that we have a good strategy to find the length of C, so let's actually find it. So now C is going to be the distance among point A and B, which if we do this properly, is going to be x1 minus x2, where x1 is A, minus x2, which x2 is B cosine of theta, square plus y1, where y1 is 0, minus y2, where y2 is B sine of theta. Right, so we have properly find an expression for C, but now that we know that Z is equivalent to this expression, can we use this result to find an expression for C squared? Well, the first thing that I notice is that perhaps I can just simplify this. I can simplify this as just being A minus B cosine of theta plus, but now 0 minus B sine of theta, well, this is just negative B sine of theta. And this is all square. If we want to find an expression for Z squared, then perhaps what we can do here is we can just square both sides. And by squaring both sides, the radical is going to cancel out with the root. So now we have that C squared is equivalent to A minus B cosine of theta squared plus negative B sine of theta. So even though we have found an expression for C squared, we can definitely simplify this because this looks, it just not look very nice or very clean. So how can we simplify this a little bit further? Well, let's start with this. A minus B cosine of theta squared. Well, that's equivalent to just A minus B cosine of theta 2 times. Plus, and now minus B sine of theta all to the second. Well, that's equivalent to just B squared sine of theta squared. So we have definitely taken care of the right hand side. So now let's distribute this and let's see what we get from this. So if we distribute this, that becomes a squared. If we distribute this, this becomes minus AB cosine theta. And if we distribute this, that becomes minus AB cosine theta again. And if we distribute this, that just becomes plus B squared cosine squared. So let me just bring this down. Well, can we simplify this a little bit further? Yeah, notice that I can combine these two like terms here. And then we do this properly. And notice that now, and these two terms that we do have here, I can also, if I just want to concentrate on these two terms here, notice that I can factor out a b squared. So now I can just rewrite those two terms as just b squared times cosine squared plus sine squared. But you might have recognized this. Recall that sine squared, well, let's do the same order. Cosine squared plus sine squared, that's equals to 1. That's one of those Pythagorean identities. So now notice that all this is really just 1. This expression right here is really just equals to 1. So now after doing all this, notice that we were able to just simplify this, because now c squared, it's equivalent to just a squared minus 2ab cosine of theta plus b squared times 1 is just b squared. And I guess for simplicity, let me just rearrange the terms. So now we have that c squared is equal to a squared plus b squared minus 2ab cosine of theta. And this, it's a very important formula for us to remember, because this is one of those. There are three ways to rewrite the law of cosine, and this is one of those ways that we can rewrite the law of cosine. What this is saying is that if you get line segment c squared, so this line segment c squared, which was our main objective in the introduction, that's going to be equivalent to a squared plus b squared minus 2a times b times the cosine of a reference angle. It is always going to be true. The well, I don't want to call it hypotenuse, but at least the length that is opposite of the reference angle, c squared, it's always going to be equivalent to just a squared plus b squared minus 2a times b cosine of our angle. And notice that this formula didn't just came out of nowhere. There was a logical pattern behind it. It's nothing more than the distance formula. It's nothing more than the distance formula. And again, this is one way to write the law of cosine. So I'm saying that this is just one way to write the law of cosine. So is there different ways to write the law of cosine? Well, we have already stated one of the ways to write the law of cosine. And this is the law of cosine to find that is in terms of c squared. So this is what we obtained from our introduction problem. So a squared plus b squared minus 2ab cosine of theta. But also, we could have used the same idea, which we're not going to derive them. I'm just going to state them. If we would have seen the same problem, but now, if we wanted to look for the line segment of B, which again, we're not going to do it, but if we wanted to just not concentrate on C, but now I wanted to just concentrate on B, or pretty much, if I find the distance from A to C, you will notice that we would arrive to this different conclusion, that A squared plus C squared is minus 2AC cosine of B. And now I guess here, for formality, even though I'm calling it here theta, note that this is angle C. So let me just fix this real quick, because it is true that it's angle theta, but for formality, since this is angle C, I'm just going to call it as angle C instead of theta. So yeah, it's C squared equals A squared plus B squared minus 2AB cosine of angle C. So let me just change that in here as well. Oops, let me change this as well. So that's good. And also, if we were to try to find the distance, if we were to use the same approach, and now if we were to try to find the length of angle A, which in other words, if we were to find the distance formula to find the distance between C and B, we could have also got a different formula, which it will be, and again, you can do this on your own. You can convince yourself that this is true, where A squared equals B squared plus C squared minus 2 BC cosine of A. So there are three ways that we can rewrite the law of cosine. And these are the three different forms that we can use when it comes to the law of cosine. So notice that these examples, or at least the way that we are written, these formulas, are all in terms of length. So c squared, it's a length square, b squared, it's a length square, a squared, it's a length square. So there are other ways that we could rewrite our law of cosine, which we could have also written as the cosine of c, that's equivalent to a squared plus b squared minus c squared all over 2ab, which in other words, I'm looking at this representation of the law of cosine, and I'm just solving for cosine squared. So c squared, take away a, take away b, divided by negative 2ab, you would have got this result. And also, the cosine of b, it's also equivalent to just a squared plus c squared minus b squared all over 2a, c, and lastly, the cosine of c, that's equivalent to a squared plus b squared minus c squared all over 2ab. I do recommend for you to just get familiar with the first three, uh, the first, second, and third representations of the log cosine, because the ones that we do have here on the right hand side are just derivation of the first three. And the most important question out of this is, what's the purpose of the law of cosine, or how can we use the law of cosine? Well, the law of cosine is just another tool that we do have to solve for sides and angles in an oblique triangle. So we have the law of sine. We have discussed the law of sine. But here we have a different tool that we can use to solve for sides and to solve for angles in any triangle, but we usually just concentrate on oblique triangles, which are just triangles that do not have a 90-degree angle on them. So let's do one example. Let's do one example. So if we take a look at the directions, it says find the three angles of the triangle shown at the right. Cool. So we want to find angle A, angle B, and angle C. Well, one thing that you might notice is that we cannot use the law of sines here. Because for the law of sines, I need to know at least one angle and its opposite side. And I don't know any of those angles. So notice that we just cannot use the law of sine. So how can we still solve for those angles? Well, we use the law of cosine. Now, notice that we want to solve for three different angles. So now the question becomes, which angle should we start solving first? And at this point, you can choose whichever angle. You have freedom over that. But at least for me, or for this example, I am going to start solving for B first. Okay, so I'm going to be start solving for B. So let's see, this is my objective right now. I want to solve for B, but now notice that I perhaps want to use this second representation of the law of cosine, because the second representation of law of cosine has the angle B on it. And notice what we have. I have A, B, and C. So if we take a look at our formula, I know little b, which in this case is 19. I know little a, which is 8. I know little c, which is 14. And the same goes, I already know that little c, and I already know little a. So notice that I have all this, I can find the numerical representation of all this, and I can just solve for b using the inverse of cosine. So let's see. Let's just get this information, plug it in, and look at our results. So now, like we stated, we are going to be using the second representation of the law of cosine. So let me just rewrite it one more time. And let's just plug in the knowns. Little b is 19, so now this becomes 19 squared equals a squared, where a is 8, plus c squared, where c is 14, minus 2 times a, which is 8, times c, which is 14, times the cosine of b. Now we have to be careful here, because this is where you might uh, make a little bit of a mistake here. Here we have three terms. So we have 8 squared is one term, 14 squared it's another term, and minus 2 times a times 14 times the cosine of c, this is a different term. So we have three different terms. We have of one term, we got two terms, and all this, it's a term of itself. Since we're solving for b, I want to isolate b squared. So I'm not going to write down 19 squared because that seems to be a big of a number. So instead of that, I'm just going to keep it all as exponents. So if I want to solve for cosine b, I want to take away 8 squared, whatever that is, which is 64. And then I'm going to also take away minus 14 squared on both sides. That way this cancels out, this cancels out. And now I'm trying to solve for cosine of b. So now I have that 19 squared minus 8 squared minus 14 squared, that's equal to negative 2 times 8 times 14. Well, let me actually multiply this instead of just keeping it like that. So 2 times 8 times 14, that's equivalent to, well, negative 224 cosine of b. So let's see what this is. So 19 squared minus 8 squared minus 14 squared, that's equivalent to 101. So notice how my expression just became a little bit more simple. Let's solve for cosine of b. So therefore I need to divide it by negative 224. So now I know that cosine of b it's equivalent to negative 101 all over 224. Remember that what we want to do here is we want to solve for b. So if we want to solve for b, I multiply the inverse. So if I multiply by the inverse on the left, by the inverse on the right, by the rule of cancellation, then the cosines will cancel out. And now I know that b is equivalent to the inverse cosine of negative 101 over 224. And we can definitely find this representation using our calculator. So now we have inverse of cosine of negative 101 all over 224, and that is equivalent 2.03. Oh, okay. So again, don't make this mistake. It should be on radian mode. So now that it's in radian mode, let's try that one more time. Inverse of cosine of negative 101 divided by 2 to 4. So there it is. That's more like it. So b, now I know that b is equivalent to approximately 116 degrees 0.80. So now notice that I know exactly the value of b now. So we're almost done, because now that we know angle b, if we go back to here, let's put this on the side. Let's put our what we just obtained here. I know that angle b, that's equivalent to 116.80. So now we want to solve for c and for a. Now, to solve for c, We could have used the same idea, but now we could have used the law of sine to solve for c now. But in this case, I'm just going to use the law of sine now. Because it's just easier to use the law of sine than to use the law of cosine. Because now notice that if I want to solve for z, now I know angle B, I know B, I know C, so I can definitely solve for angle C now. So let's use the law of sine. And again, we could find angle C the same way that we just did for angle B, but now plug in the information for the first representation of the law of cosine. But I'm just going to use the law of sine because it's just way easier to solve for angles whenever we can write it into terms of the law of sine. So the law of sine says that sine of c over little c, which is 14, that's equivalent to the sine of b, which we know what b is, over little b. Oops, it's not just little b because we actually know what the value is, which is 19. And now we can definitely solve for c now. Because now if we solve for c, now this becomes the sine of c, it's equivalent to just 14 sine 116.8 all over 19. And if we want to solve for c, let's multiply by the inverse. So now I know that c is equivalent to the inverse of sine, evaluated at 14 sine 116.80 all over 19. And again, this is something that we can use our graphing calculator for. So let's just find what that value is. So inverse of sine, first parenthesis, we got 14 times the sine of 116.8. This parenthesis close to the sine, this parenthesis close to the numerator, and divided by 19. And this closes the sine inverse. So now I know that angle C, it's approximately 41.12 degrees. We could have gotten the same result. We would have gotten the same result if we would have plugged in little a, little b, and little c on the first representation of the law of cosine. But as you can see, the law of sine is just way easier. So now that I know that angle C has a value of 41.12, the only angle that we're missing is angle A. But for angle A, I don't have to use the law of sine or the law of cosine because I know that the sum of the interior angles is 180. I know B, I know C, so we can definitely find out what A is. So now, angle A, it will be 180 minus 116.8 minus 41.2. So now, let's see what that is. So we got 180 minus 116. So now I know that angle A is 22.08 degrees. So this is one of the ways that we can use the law of cosine. Again, the law of cosine is just a tool that we can use to solve for either sides or angles in an oblique triangle.